9 interesting facts about the James Webb Space Telescope. Did you know that the James Webb Space Telescope needs to stay below -370 degrees Fahrenheit to function correctly? Let's be honest for a moment. The James Webb Space Telescope, JWST, is one of the world's most significant technological marvels. Not only is it a highly advanced telescope, but it also operates in space and sends back data to Earth. If you've been wondering about all the hype surrounding the James Webb Space Telescope, get ready to have your mind blown with some out-of-this-world facts. 1. The James Webb Space Telescope is named after NASA's second administrator. Originally called the Next Generation Space Telescope, the JWST was renamed in 2002 in honor of James E. Webb. Webb served as the highest-ranking official for NASA from 1961 to 1968 and played a crucial role in transforming NASA from a disconnected organization into the highly coordinated machine it is known as today. Webb also oversaw the Mercury and Gemini programs, as well as most of the Apollo programs. However, it's worth noting that naming the JWST after Webb was controversial, as he had been accused of being complicit in systematically firing any employees suspected of homosexuality. 2. It took 26 years to go from proposal to deployment and full operation. The road to completing the JWST was anything but smooth. It was proposed in 1996 with a planned launch date of 2007. However, due to skyrocketing costs, the mission had to be replanned multiple times, leading to further delays. In 2011, 4 years after the initial launch date, the JWST's design phase concluded, and construction of its parts began. 5 years later, the telescope was finally assembled, and testing commenced. In 2018, during testing, the telescope's sun shield ripped, revealing 344 possible single-point failures. The subsequent years were spent finding solutions and retesting everything. Eventually, the telescope was launched on December 25, 2021. 3. The JWST's instruments allow it to capture images of objects 100 times fainter than the Hubble Space Telescope could. Equipped with 4 scientific instruments, a near-infrared camera, a near-infrared spectrograph, a combined mid-infrared camera and spectrograph, and a combined near-infrared camera, spectrograph, and guidance sensor, the James Webb Space Telescope possesses unprecedented abilities to gather data about the universe and its origins. 4. The James Webb Space Telescope can see back in time. The light emitted by the first galaxies when they formed was in the visible spectrum. However, as light travels longer distances, it shifts into the infrared spectrum. By capturing images using infrared sensors, the JWST can observe the light emitted by the first stars in a way that no previous telescope could. The ability to peer into the origins of our universe is one of the most significant features of the JWST. 5. It can also see through clouds of space dust. Space contains its fair share of dust, which poses a challenge for regular telescopes. This is especially problematic since galaxies emit a lot of dust during their formation. Infrared light can pass through dust clouds more easily than visible light, enabling the JWST to capture clearer images of galaxy formation compared to any other telescope. 6. The James Webb Space Telescope must be kept below -370 degrees Fahrenheit, -223 degrees Celsius, to function correctly. Infrared telescopes are sensitive to any form of heat, rendering them ineffective. This is why we cannot use infrared telescopes on Earth or the Hubble Space Telescope, as there is too much heat interference. While space is colder than the telescope's operating temperature, it is only the case for objects not exposed to sunlight. To address this issue, the JWST has a sun shield comprising 5 layers of reflective film as thin as a human hair. This shield reflects sunlight and prevents it from interfering with the highly sensitive instruments. However, the telescope can only observe 40% of the sky at any given time because it must always remain in the shadow of the sun shield. 7. The JWST orbits in a stable position 1 million miles (1.6 million kilometers) from Earth. Although it does not orbit Earth, the JWST has been placed in the Sun's orbit at a position known as a Lagrange point. Lagrange points are unique positions in space where one object can easily maintain a fixed relative location with another. In this case, the JWST will essentially orbit the Sun while maintaining a constant relative position to Earth, with only occasional adjustments to its motion. 8. To fit into its launch vehicle, the JWST had to fold up like the world's most expensive piece of origami. When combined, the telescope's mirrors alone have a diameter of 21 feet, 6.5 meters, and the sun shield measures about 46 by 70 feet, 14 meters by 22 meters. However, the available space within a rocket for a payload is limited and insufficient to accommodate such dimensions. The solution, in the end, was highly sophisticated and elegant: the entire telescope folded in on itself. Once it reached its destination, it took an incredible 2 weeks to gradually unfold, piece by piece, before any of its instruments could be tested. 9. The JWST's launch and deployment went so smoothly that its expected mission length was doubled. A small amount of fuel is necessary to maintain the JWST's stability in its orbit around the Sun. Conservative estimates indicated that the mission would have approximately 10 years of life based on the fuel needed to position and deploy the telescope. However, thanks to the exceptional accuracy of Ariane 5, the JWST's launch vehicle, significantly less fuel was required to position the telescope. This achievement is monumental, as the only thing holding back the James Webb Space Telescope from operating for a much longer duration is fuel. It is a remarkable accomplishment that NASA could only have hoped for. One of the most exciting aspects of the James Webb Space Telescope is the idea that countless current and future scientists, astronomers, and ordinary individuals like you and me will benefit from it. While we gaze up at the night sky, the JWST will delve into its depths, bringing us closer than ever to uncovering the true origins of our universe. All of this is made possible by this incredible piece of machinery.